My name is Laura. I'm going to be presenting on multimodal routing with Python. I am a data analyst by day. I work mostly in SQL, so I wanted to see what I could do. No, sorry, 1 second. I wanted to see if I could expand my horizons beyond just SQL. I've done a little bit of Python before, but I worked a lot in Jupyter Notebooks. I can't take credit for that sweet meme, but if you know the talk that I'm talking about, where it's sourced from, you'll understand there's a lot of really good ones there. I wanted to get out of the sort of bad habits that are discussed in this, this talk that was made at JupyterCon by Joel Grus. So I wanted to, in addition to writing better code and exploring different libraries, I also wanted to sort of interrogate my own practices and try to do better. So I also have a background in geography, but I have never worked in it professionally forever, not since college. So I wanted to look at what sort of options were available to me for geospatial analysis in Python for my project. So as a user of Chicago's public transit system, I'm constantly annoyed at the hub and spoke model, which makes it very difficult to go anywhere that's not downtown. So I wanted to build a multimodal routing app that will include trains, buses, and divvies, and that will include more than one option. So Google Maps, you can use public transit, but there's no divvy option. So that was my goal. So I pulled data from the CTA's API for arrival times for trains and buses to sort of construct a history of arrival times for the 25 most highest ridership buses, and also for all of the train lines, to try to determine the length of time between each stop. Divvy, I don't have to do that because we already have the data. I'm really glad that Emily went before me. Because you already know what's available from Divvy. And potentially, I would think I'd like to expand my project to even more like dockless bikes and scooters that we might find in the Chicago River when people get angry. So I used a couple new libraries to me. I used GeoPandas, which is like pandas, but spatial. I also use OSMNX. It's very hard to say. Thank you so much, Emily, for explaining it, because now I don't have to. But I use that to build my network. So I made calls to the CTA's API. I stored that data. I stored it in Postgres. I eventually realized I needed a place to put all of my data. So I stored it in Postgres. And I learned a lot of fun things about what you can do in Postgres. This is an example of OSMNX. Just in case you're curious, all you need to do is give it like a place name, and you can get a full road network or walking or bike. You can just specify the network type. It's really cool. I also realized when I put my data in Postgres that I can do a lot of the spatial operations that I was doing for my routing app in Postgres also. So I thought I would compare some of the spatial operations I've been doing in GeoPandas to Postgres, and surprisingly or not, as someone who's used to SQL, I found Postgres a lot easier, and it was also faster for the data set that I was working with. So what did I learn? I didn't quite finish my routing app. It was a big, tall order, so scoping is important. Also, anyone that's done the mentorship program and has been to all of the project nights is maybe familiar with what this graph is representing, but we have been building various different tools to help us track our time as mentees, writing, coding, meeting, debugging. So my biggest pie piece is the why. This is a pie chart. I'm sorry, bad analyst. So the why. So I spent a lot of time not debugging, but trying to figure out how to make things like, what's wrong with pip? Why won't pip install? What's wrong with brew? What's wrong with my Docker container? What's wrong with Postgres? And I learned a lot through all of that Googling, but it was really tough, and that was the majority of my time. Thank you, everyone in the mentorship program. Thank you, Ray. Thank you, my mentor.